Yeah, Dr. Senimira, the resource person of the day. Dear faculty members, dear distinguished participants. Good morning to every one of you. I welcome Dr. Senimira, one of our alumni. So, a distinguished student of our institution. He finished his degree in 2006 from our college.
நீ சும்மாவே கைய வச்சு என்ன நான் கைய வச்சுக்கிட்டு சும்மாவே இருந்தது படக்கு படக்கு ஆஃப் ஆகுது பைத்திரம் இங்க வாழ எனக்கு படக்கு படக்கு நெஞ்சு அடிக்குது பைத்திரம் சவுண்ட் வரல வாழ ஆஃப் ஆகுதுல சனிய யூடியூப்ல தான் பாக்குறான்
Hello. Hello.
Sir, sorry to interrupt you.
Sir, unmute.
Mic, உங்க mic நீங்க unmute பண்ணிட்டு.
Sir, unmute பண்ணி. கேக்குதா சார்?
இல்ல சார், ரொம்ப நேரம் கேட்கல சார் நீங்க சொன்னது ஸ்டார்டிங்ல
வீடியோ ஆன்ல இருக்கு. சித்ரா வீடியோ ஆன்ல இருக்கு பாருங்க. சித்ரா.
Okay.
நீங்க தெரியுங்களா?
Just I want to introduce our resource person. First of all, I thank Dr. Barbara Milla, Deputy Director of the Institute, Head of the Department of Chemistry, University of Cologne. She has permitted our resource person to go through this presentation. So we thank him and welcome her also. Regarding Dr. Senimira, he is one of our alumni who finished his degree in 2006 and went to Jamal Muhammad College for his PG, and then he joined in CLRI Madras for his research program. When he was studying in our college, I observed that he was a distinguished and he is putting all sorts of efforts in learning activities and also participating in so many things arranging on behalf of the department. He used to refer so many books from the local library. He only showed me that such books are available in the local library, that is for the chemistry faculties. I thank him. Then, as far as his research is concerned, at presently he is working as a scientific researcher, Department of Aerogels and Aerogel Composites, Institute of Material Research, German Aerospace Research Center, Linde, Cologne, Germany. His objectives are to become a resourceful person as an academician and a scientist in polymer material and chemistry. That shows his commitment. He didn't say that I want to become a scientist. He is saying that he wants to become a resourceful person. So when he becomes a resourceful person, he is not useful for him alone, for his family alone, or for his country alone. He is going to be useful for every nook and corner of this universe. So I thank and congratulate Mr. Senimira for his dynamic and noble objectives. Next. His research interest is in recycling agro waste materials. Today, we are towards the green world, where we are speaking a lot about recycling and reusing. His research is in that direction. He has published 18 research journal papers in world-renowned journals. He has participated in, he is being the part of the 2 chapters in books. His citation index is 522, H index is 14. He has contributed in organizing one conference, participated in 12 seminars and all these things. Invited lectures, he has given 5 invited lectures, guest lectures 4, project gone through 2 projects, techniques. He is well versed in almost all techniques in chemistry. With this, I invite Dr. Sinimira. Before that, I request many of you have registered for the first day program, and if it is possible and if it is convenient, all the 6
Sir, 1 minute, sir. I think your mic is going mute, sir. I request. Hello, sir.
Siri.
Sorry to. We could not able to hear your voice.
again it has. Sir, Balu sir, நீங்க
Maybe.
தான் மீட் பண்ணிடுறீங்க.
Okay.
Sir, maybe can
One
you
sec.
take over the control of all the participants, sir? That's the best.
Participants மட்டும் ஏதோ நாய்ஸ் வந்துட்டே இருக்கு சார். அதான் மியூட் ஆல் கொடுத்தேன்.
பாலசுந்தர் சார்,
சொல்லுங்க.
இது நம்ம பிள்ளைக்கு பூரா வீடியோ ஆன் பண்ணிருக்கு. ஜூலி, சித்ரா, ஜூலி, நிவேதா, சித்ரா, சிவகுமார்.
Let it go, sir. Let it go.
Okay. Continue. We'll continue.
Okay,
With this, I conclude my welcome speech and introduction of the chief guest. I'm sorry, I think in between there were so many interferences. I thank each and every one of you for your participation, and I invite our resource person, Dr. K.C. Nimira, to deliver his answers.
Okay, sir. So I'm going to share my screen.
APG, sir.
So, would you able to see my screen, sir?
Yes, your screen is available.
Yes, sir.
What's about your web camera? Okay, well.
Okay, sir.
Okay.
Thank you, my dear Professor Dr. Susai Manikam, for the kind introduction, and all the faculty members of chemistry department. So I'm going to present my talk on aerogels, super materials for the future. So I'm working as a scientific researcher at the German Aerospace Center of the Cologne site. So before going into my scientific talk, I would like to give a brief introduction about my institute for the awareness of our young student community. So yeah, as you all know, German Aerospace Center is a federal government funded institution. It has several sites throughout Germany. Overall, it has 9,000 employees with 26 locations throughout Germany with 51 institutes and various facilities. Apart from Germany, we have 6 international locations. There is Paris, Brussels, Tokyo, Washington, and includes Canada also. And moreover, we have 10 different company spin-offs in 2018 and 19. And also, DLR is part of the member of Helmholtz Association. So we have 3 different sectors. One is research institution, mainly 7,500 employees work on research-based projects. Another 1,000 employees concentrate on project management agencies. And apart from that, we have 250 employees mainly for the space management. DLR site is at Cologne is the main site. And also we have a site of ESA, European Space Agency. Both were located at Cologne site. Yeah. So we have around 178 research infrastructures with related to the R&D field of DLR, and also we share different research institutions, and we have different industrial partners. So we work on the field starting from wind tunnels, aircrafts, research power plants, energy storage and test facilities, control systems, test benches, simulators, research vehicle and platforms, compact test range, high performance computer, sounding rockets, medical infrastructure. So the main core area concentrate with the space, energy, transport, all these areas. So yeah, I'm basically from Institute of Material Research. So our institute mainly focus on research across scale. So we work on material development and structures and for the further production. So mainly I belongs to Institute of Material Research, which is headed by Professor Heinz Wohenreiter and Professor Dr. Barbara Miller, who is my head of the department as well as the deputy director of the institute. So Professor Heinz Wohenreiter is also associated with the Institute of Structures and Designs at Stuttgart and Augsburg. So our aim is to from materials to structures and production, possible production. So this is the overall view of our department research activity. So we work on all the areas of aerogels, starting from inorganic aerogels, organic aerogels, and biopolymer aerogels. So this slide give an overall view that we work on silica-based aerogels, resorcinol formaldehyde-based aerogels, and biopolymer-based aerogels, and also carbon aerogels. Then we work on honeycomb-based aerogel composite structure and fiber reinforced composites. Then also we work on 3D fiber reinforced polymer composites, and also we work on granular aerogel composites for super building structures. So this is the overall view which can give us our activity at the Department of Aerogels and Aerogel communities, composites. So in specific to our department, you can see the picture. This is the picture of our boss, Professor Barbara Milo, who is the head of our department as well as the deputy director of the Institute of Material Research. She also holds a professor position at the Department of Chemistry at University of Cologne. So recently, one of our work based on chitosan aerogel was highlighted in the magazine of DLR. So this is one of the beautiful and unique structure of like a flower kind of structure that we have recently developed in our group. So yeah, this is the overall view about our institute and our DLR and especially our group. Now going into more specific, I will focus on my talk on aerogels, super materials for the future. So yeah, first question you can all the students especially can ask why the new, maybe some of you heard first time the word aerogels. Why aerogels are the next super materials? So I just like to show one video. Okay.
Baby girl.
போன் கொடு, அம்மாவோட போன் எடுத்துட்டு யாரு எடுக்கணும்? சரியா வருங்கா
It is one of the famous picture of aerogel. So at least by seeing this video, you all know the why aerogels are super materials. So because of its excellent properties and wide application. So for the past 30 years, more than 30 years, our group is working on the development of various kind of aerogels for different applications. So in going into the more detail, so for anything you need inspiration from nature or some person. So before starting my PhD, my boss, Professor Mandal and Dr. S.N. Jaishankar, they just asked me to, you are going to work on gels. So during my literature, I found that the famous quote from E.G. Rocho, the Earth's crust and all the molten magma beneath it, and the moon and Mars and Venus are composed of silicates of the common metals. We stand on a world composed of silicates, and we use the same earthy stud to build houses and public buildings. So we are literally surrounded by silica and silicates in all our lives and are even buried in the stuff when we die. So somehow I got a very sentimental touch to this quote. So then I started to work on silica aerogels. So I have divided my presentation like this is my structure of the presentation. So introduction to aerogel, then silica aerogels using ionic liquids, cellulose aerogel microbeads, RF aerogel microparticles. Then I will give my summary to end up the session. So before that, you all know nanometers, the material which falls from even less than 100 nanometer to 1000 nanometer are called as nanomaterial. There are a variety of nanomaterials starting from nanoparticle, nanotubes, nanoribbons, nanofibers, nanodots, and even nanocubes. So there are variety of methods available to prepare these kind of fantastic materials. That is like a top-down approach, bottom-up approach, CVD approach, salt gel approach, hydrothermal approach. So out of these method, I am interested on a salt gel approach. Why I have a fascinate about this salt gel approach? Because it has a very easy procedure. Anybody can use this method to prepare nanomaterials and standard conditions. You have to use only standard temperature and standard pressure, and moreover, especially the precursors are very cheap in cost. So I just concentrated on a salt gel method process to produce these kind of aerogel materials. So what are salt gel process? You can see this picture. You have a liquid. So salt is nothing but particles of 0 to 100 nanometers, which are dispersed in liquid phase. So when you apply some kind of stimuli, that is pH, temperature, or salt concentration, they are going to change a solid network. So it is called the transformation of a colloidal liquid into a solid network. It's called a salt gel process. So yeah. So you can see this is the famous video from our group. So it is depicts the preparation of silica aerogel. So we are going to mix two different precursors, mainly based on silicates in presence of ethanol and ammonia, which immediately forms a solid gel network. So you need only very minimum conditions to prepare such a material, and the preparation time is also very short. That is the advantage of this salt gel process. To give more aestheticness to the videos, I just give one more slide from one more video from our group, which depicts the preparation of resacinol formaldehyde aerosols. So which gives a development of a very good color. Sorry. So these kind of reactions, any common man, any layman, so you don't need to be a chemist or material chemist. Anybody can do such a chemist to prepare these kind of nanomaterials at a standard room temperature, standard pressure, and with a simple mixing of the reactants. Yeah. So this slide can give you more importance of the salt gel process. So you can see we have a solution. So I'm going to prepare a salt. Then I'm going to convert, get up a gel. So during this salt gel process, you can tune this material into different forms like a fiber, powder, monolithic, and more powder and patterns, films by using variety of techniques, starting from spray drying, pulling down, pulling up approach, even dip coating. So you see the wide applicability of and diversity of this process. So you can you need only standard conditions, so you can prepare different dimension of material by adapting different processes for a possible multi applications. So that is the advantage of sol-gel process that fascinates the researcher community to work more on this sol-gel process. Yeah, I already okay. I already told aerogels, they are nothing like a fog air. So they mostly composed of 99% of air. So you're going to mix the reactant and form a sol particle. Then they form a network. Based on the drying, they are going to form either aerogels or gelogels or cryogels. So depends upon the drying conditions you apply. So yeah, you can see the famous aerogel pictures from Professor Nicola Husing, Austria. So it was a picture of silica aerogels. And very interestingly, you can see how even though they are very lighter than air, almost they light as equal to air, but they have a very good strength. So you can see the picture on the right side. So the aerogel was holding a 2 gram, I think 2 kg of brick. So that much strength it has. So because of these fascinating properties, so more people are working on such a materials. So still a lot of things need to be explored. Yeah. So with regard to our group, we work on various types of aerogels. So you can have a doubt, what kind of material can be gelled? Any material, anything which can be dissolved and can form a gel, you can make it as a gel. So we work on inorganic aerogels like silica, the water glass. So sol-gel process is not new to our human community. It was followed from the ancient times for clay pot preparation and so on. Several, you can see the history. Yeah, we work on silica, titania, zirconia, and mixed oxides. So apart from that, we work on organic aerogels based on resorcinol formaldehyde, meramine formaldehyde, resorcinol minamine formaldehyde, even polyimide. So they have the excellent thermal insulation property and wide application. Moreover, these organic aerogels can be converted into carbon aerogels for possible oil absorption application, water treatment, and electrochemical applications. We also work on a biopolymer like cellulose, starch, chitosan, and alginate aerogels. So they have a very good application in terms of biomedical applications and air purification, water purification. So these kind of so you can prepare all type of aerogel material for the application you want, and you can tune the property as much as you want. So our group is focusing on all the fields. Yeah. So I explained overall view. Now you can ask, sir, what is the application? What is the interesting property? So I already told they have a ultra low density. So as equal to as lighter than air. You see the carbon aerogels, graphene aerogels produced from a group from China. It was floating on the petal of the flower. So that much ultra low density, and especially which can absorb liquid of 900 times of its volume. That is another interesting property. And moreover, ultra thermal insulation property, especially when you are constructing houses, you have to insulate them. So we have recently we have developed a honeycomb structure based aerogel which has an excellent thermal insulation property. So you can see this video. So we have shown one side of the aerogel to flame and kept it for almost 5 minutes. So at the end of the video, you can see the other side of the aerogel. So that your flame does not have an impact on the other side of the aerogel. That means you have a very good thermal insulation property, which can give a insulation even when you have a fire in your houses or any building insulations. So it can protect huge damages to the structures. And high temperature thermal insulation, especially aerospace applications. When man mission is happening, so when it undergoes a higher temperature like 2000 degrees Celsius Fahrenheit or 4000 Fahrenheit, so such a material have a fascinating property. Yeah. So another important aerogel from NASA, polyimide based aerogels, They are ultra low thermal, flexible in nature. So you can prepare these kind of polyimide based aerogels for thermal insulations in aerospace applications. Apart from that, in biological field, since they have a nanopore size, high surface area, so you can encapsulate any drug into it or any biological molecule. So they act as a host and stabilize their stability, and they deliver them on time, especially with respect to time dependent drug delivery. Yeah, this is another interesting work from a group from Lawrence Liverpool laboratory. Okay, 1 minute. So recently, Lawrence Liverpool National Laboratory developed a 3D printing of a graphene aerogels for possible electrochemical applications. So nowadays, more researchers were working on multiple energy sources. So which has multi-featured properties like more flexible, super flexible material, super conductive material, and super energy storage material. So they are going to rule the world of energy in the future. Yeah, they have low electrical resistivity and as well as a good electrochemical property with high compressibility. So you can plan for flexible electronics or wearable electronics. So the field is wide open to anybody who want to contribute in the area of electrochemistry. So apart from that, this is another field. Even those who are staying in Chennai, they could have faced the problem. 2 years back, there was a oil leakage in the marina, one of the second largest beaches we have. That's our pride, but we polluted it. So another problem throughout the world, oil spillage removal. So these materials have a property of absorbing large amount of liquid in its volume. So this is the work from our group. So we have developed, we have shown aerogels can used for removing oil spillage in water. So in the left side, you have a pure water. The other side, you have a water contaminated with the oil. So as much as it can help us to remove all the oil. So it has a huge potential in the oil spillage application and the oil industry. So apart from that, because of its varying density and ultra low density, ultra low thermal conductivity, so they are used in the panels of a Mars mission to collect super dust particle, that is hyper velocity particle. They are not easy to catch. So by tracing them, we can study what is the history of our Earth. So that is, and minerals, what are the minerals found in the space and different planets. So this is also one of the artistic image from NASA. Yeah. So with this introduction and applications, I just go on to focus on my work, what I have done in this 7 years of my, almost, I started my PhD in 2009. So 11 years of my PhD after my PhD. So this is my first work. So always for a mother, the parents, first baby is special always. So like me, any researchers getting published, it's like a giving birth. So this is the first work I started like a kid crawling and started to walking. So the title of my first work is mesoporous and biocompatible surface active silica aerogel synthesis using colline format ionic liquid. So this work was highlighted in the CSIR annual report of in 2009 and 2010. So I must thank my professor Mandal and my co-supervisor Dr. S.N. Jaishankar for giving me the liberty to work on what I think. They never forced me to do something. They asked me to go open. It's up to your choice. And they gave the support and flexibility. So already I explained what is the process of aerogel. So, but yeah, in nature, if anything has an advantage, definitely it has a disadvantage. It has a nanopores, high surface area, ultra low thermal conductivity, and yeah, ultra density. But what is the disadvantage? So the major disadvantage with the aerogel is gel shrinkage and matrix collapse, because the process involves aging and drying. So during this time, a lot of solvents will be evaporated like ethanol, methanol, water. So this is going to shrink your material and collapse the pore structure. So yeah, everything is going to be collapsed. So you have a good material, but at the end, you are going to end up with something like completely shrunken. So what is the solution? Ionic liquids. So people tried different methods like a supercritical drying, or apart from ambient drying, they tried supercritical drying or freeze drying. But the problem, they are expensive and harsh environment. Yeah, so we have to go with the easy process. Then we can think about bulk production. So yeah, that's why these fascinating liquids, ionic liquids, they are like nothing like a. So you see the contradictory word. So generally liquids. So we have ionic. So we have generally ionic solids. So they are special with ionic liquids. They have both cation and anions, but they exist as a liquid at room temperature. That is the beauty of these materials. They have different properties like a negligible vapor pressure and different ionic environment, high thermal stability. So this property help us to achieve longer aging time. Thereby we can avoid the shrinkage of the aerogel materials. So this picture you can see, one is sodium chloride. It's ionic salt. So it's a solid in nature at room temperature. The other one is 1-butyl-3-methyl imidazolium bis trifluoromethyl sulfonyl imide. So which is a liquid at room temperature. So that is the beauty of these ionic liquids. So these are some of the examples of imidazolium based ionic liquids. So yeah, and yeah, still it has also another difficulty, because most of the imidazolium ionic liquids are toxic in nature. So if you want to work on biomolecule applications to giving some drug or protein into it, the toxicity will affect the stability of the protein. So we have to think multi-dimensional property of your material. So that's why we have chosen choline based ionic liquid, that is called a bioionic liquid, because we all know in our body we have a choline based enzyme which gives a lot of biological action. So this is the choline choline cation. So scientists developed by changing different anions from hydroxyl, from acetate, tartarate, choline, saccharate. So they end up with choline based ionic liquids. So they are room temperature ionic liquid. They have green property. They can stabilize the protein at room temperature. So you have a multi application of reducing gel shrinkage, matrix collapse, and retaining the stability of biomolecule. So yeah, then I started to develop silica aerogels using choline formate ionic liquid at room temperature. That is another advantage. So we mix all together at room temperature and leave it for 1 week for gelation and drying it in the ambient conditions. So I prepared aerogels without any ionic liquid, aerogels with ionic liquid. Then I tried to remove the ionic liquid using Soxhlet extraction. So overall, your gels with without ionic liquid has a higher shrinkage and matrix collapse. You can see they have come out of the walls of the container, but here gels with ionic liquid retain its original shape. That means lower shrinkage. Yeah, with respect to FTR spectroscopy, we can study whether the ionic liquid present in the system, what kind of interaction it gives with the hydroxyl groups in the 3400 centimeter region, and moreover with respect to silica network. So and moreover we remove the ionic liquid. So in order to confirm whether the ionic liquids are removed from the system, but it's not possible because of the nano confinement of the liquid. So you can see this picture. There is a trace amount of a characteristic peak of ionic liquid. So you have a little traces inside the nanopores of the gels. So based on the FTR results, we try to give some schematic representation of the silica aerogel surface for possible functionalization application. So you have a hydrogen bonded, more vicinal hydroxyl groups without any ionic liquid. And moreover, your hydroxyl groups are interacted with the ionic liquid in presence of ionic liquid. Once you remove the ionic liquid, the surface hydroxyl groups are isolated. So this gives us the possibility to extend for further surface functionalization. So you can functionalize the hydroxyl group with any group, depends upon your need. Yeah, and moreover, with respect to sol-gel process, rheological property is important. So how the rheological property, that means your gelation gelation temperature, and complex viscosity behavior is changes by adding ionic liquid. So you can see the gelation temperature is yeah, it greatly increased when you have a ionic liquid. So it gives a longer aging time and allows the network to form slowly and have a more stable structure. So, and also it facilitates the formation of a silica network, since we use a tetraethyl orthosilicate as a precursor. Yeah, and another interesting property of these materials with surface area studies, isotherm studies. So BET isotherm clearly gives us the idea that all are typical type 4 isotherm with a mesoporous in nature. And moreover, when you have gels with ionic liquid, you have a lower surface area, but you have a higher pore size. That means that your pores are filled with ionic liquid, so which retain original pore size, and also it gives more agglomerates. That's why you have a lower surface area because of the agglomeration, but because of the lesser shrinkage, you have a higher pore size. So you can retain its nanoporous nature. So you can see the pore size distribution. So samples without ionic liquid have higher pore surface area, but they have a shrink and they have a lower pore size. So you cannot access the pores of your material for possible any application. And you can see the morphological features with respect to ionic liquid. So in case of gels without ionic liquid, they are more dense in nature. So they are shrink, and with ionic liquid, they are agglomerated in nature. Once you extract the ionic liquid, they give a porous structure. So this was the effect of morphological with respect to the ionic liquid amount, ionic liquid content. And moreover, since we use a biocompatible ionic liquid, we want to study what about the biocompatibility, because I associated with the Central Leather Research Institute. Since we more fascinate and work on stability of collagen and conversion into different materials, so I just my aim was to incorporate some collagen or bovine serum aluminum to see the stability at room temperature. So for that we studied MTT assay to see its biocompatibility. In comparison with the control sample, the gels prepared with the ionic liquid exhibit higher cell viability as well as proliferation. So that means when you have an ionic liquid inside your gels, they retain its biocompatibility, have a good pore size and less shrinkage. Yeah, so it explores the possibility of further application into encapsulation of biomolecule, as well as for a possible biosensor application, and stabilize the proteins at room temperature. That is one of the, because proteins are very sensitive to temperature. So once you give a temperature, they will get denatured. That's what happening when you cook a egg. So you have a protein in a raw egg. So once you cook, they get denatured. Then we are going to eat. So such a thing should not happen when you use such a kind of material at room temperature. So you can stabilize the protein at room temperature. Yeah, so this was my very first work. As I already told, this was my first child in terms of my research. So after finishing my PhD, then I got a prestigious DLR DAD fellowship from DAD Germany. I got a chance to work with Professor Lawrence Radke and Professor Barbara Milo to start my postdoc in 2015. So they asked me to work on developing cellulose aerogel beads. So yeah, first I had an experience with the silica aerogels. Then they give me a chance to switch my field from biopolymer to inorganic aerogels to biopolymeric aerogels. So I worked on developing another polymer, that is biopolymer cellulose, another dimension of the material, from monolithic material, gel material, into a micro bead. So I worked on cellulose aerogel micro bead and its development and its characterization. So we all know cellulose is surrounded by us. It's one of the highly available organic polymer in the earth. So which has a beta 1,4 class linked unit. So it's a natural polymer. It has a structure of this, and it has a different source, starting from wood, 40 to 50%, and cotton fiber, then cotton, then bacterial cellulose. So almost it has a huge demand and production throughout the world. And also we generate a lot of waste from cellulose, especially paper waste. So there is a demand to utilize these natural resources as well as recycle the paper waste for the materials of interest. So yeah, our group, again coming to our group, we work on different kind of cellulose materials, starting from cellulose aerogel monolithic, cellulose sheet, that is paper, then cellulose fiber, then cellulose beads. So I was asked to develop cellulose beads for a possible air filtration application in the cabin, aircraft cabin, as well as for a water application. Because when lot of number of people are traveling in the aircraft, so you are going to, the air is going to circulate it. So our aim is to extract the carbon dioxide from the system and purify the air and apply for a recirculation. So yeah, they are cellulose beads are spherical in nature. So the main drawback, dissolution of cellulose, because it has a very high inter and intramolecular hydrogen bonding. So you cannot dissolve them in water. So you see the contradictory of nature. We have a large amount of cellulose available in nature. So we have a large amount of water. So, but we cannot use them for dissolving cellulose. So we need to find some special solvent. So yeah, cellulose has a solubility at a high pH of close to 14. So you can dissolve at a high pH. And another thing, you have to shape them in beads. So it has 3 stages. So you have to dissolve, you have to shape them into beads, then you have to regenerate. So it's a critical. So you have to work on all these stages simultaneously and get up with a bead. So we can prepare different sizes. Yeah, from cellulose fiber solution to beads. So these are the different methods available for shaping into beads. Very conventional dropping, like a water droplet, then jet cutter, then spinning drop atomization and spinning disc atomization and dispersion. So our group work on dropping technique at the laboratory level, and for the possible higher production, we work on jet cutter. Yeah, I already told I have to dissolve the cellulose. So I have to find a right solvent. So I have used a sodium hydroxide urea medium with a different concentration with a little zinc oxide addition, which gives a very maximum solubility of cellulose. And I have to drop it into an anti-solvent, that is hydrochloric acid. So you see the basic, it's a very basic chemistry. So especially for a bachelor student, you don't need to think too much for doing your wonderful research. So we just use a very basic sodium hydroxide urea to dissolve your cellulose, and we drop it into hydrochloric acid bath. So we dissolve in a base and we regenerate in the acid bath. So it's an anti-solvent. Yeah. So this is the recipe what we have used. So different concentration of sodium hydroxide, urea, and water with different additive amounts. Especially this zinc oxide has an amphoteric property which can disturb all the crystalline as well as amorphous phase of cellulose to achieve the maximum solubility. Yeah. So we are developing beads using a dropping technique. So you can use 100 grams of solution per hour with a particle tuning of 1 to 3 millimeter. So it has a easy operation, but a difficulty in bulk production. So the other one, we have a very good jet cutter. So we can use 0.1 to 20 kilogram per hour. You see the bulkness of the instrument, and we can tune the particle from 0.2 to 2 millimeter. So this is one of the video from my work. So I'm going to add cellulose solution through a very basic setup. We used a very basic setup like a plastic dropper into a acid bath. Once it touches the liquid surface, it regenerates, it forms a fine layer. Depends upon the penetration of your hydrochloric acid into the system, it regenerates completely. So it takes within a fraction of seconds. So overall, maybe 5 minutes, we have to leave it in the hydrochloric acid, then to form a complete stable beads. Then we have to leave it overnight to get a completely regenerated beads. So especially for the bachelor students, so it is very, so you can design your work from easily available materials, easily available sources. So research is not nothing like something going and doing in the Mars or something. You don't need to think that you need extra superpower or super thinking to do it. So you need to understand the basic chemistry behind that and work with the basic system. Then you come up with the interesting material that is useful for a human being. Because I always feel that there is no barrier for irrespective of religious, caste or skin, anything. I will, there is no barrier for knowledge. So yeah, it can be used for any human being or any living creatures which lives in the world. Because we are not only living in the world, we share the world with other organisms. So this is another thing. Apart from laboratory development of cellulose bead, we work on jet cutter technology to produce large quantity for industrial application, especially cosmetic industry, drug industry, and so on. So we have this wonderful setup in our lab. So you are going to pass the cellulose solution with a different concentration into this nozzle, fine nozzle, and we are going to cut the solution through a jet. So which is going to cut in the form of a cylinder, depends upon the gravity pull. So it is going to shape in the form of a bead. So we need a regeneration bath. Once it touches, it regenerates into a bead. So you need such a stirring to avoid the sticking together of the beads. Yeah, so since we have done initially at the laboratory level, you can tune the bead size by changing the nozzle size, height between the tip of the nozzle and the surface of the bath, and even stirring speed of the coagulation bath. So you can play with that and prepare a variety of beads with the different sizes that can be suitable for any application. Especially since more a lot of students of girl students are available, especially these kind of beads have a huge potential in cosmetic industry. So you can incorporate any active ingredients into these beads. So when you use these kind of bead based cosmetic creams, so they're going to deliver any ingredients or which gives a special property to your skin. So it has a multiple application, especially in cosmetic industry and drug delivery applications, and absorption industry with respect to water treatment and water purification and air purification. Yeah, so you can see the overall view of bead without any zinc oxide. This the picture B is with zinc oxide. So overall they are spherical in nature, but there is a difference in the surface. So you have a very short fiber and more dense fiber, more dense fiber. But yeah, when you have a zinc oxide, which has slightly longer in fiber in nature, and moreover, pristine cellulose has a two structure. One is cellulose 1 and cellulose 2. But once you dissolve the cellulose in sodium hydroxide and regenerate, so mostly it has a cellulose 2 structure. So this is the SCM pictures of cellulose aerogel beads without any zinc oxide and with zinc oxide. This is a cross section. So we made a cross section of the beads and did the SCM pictures. So you can see here the beads without zinc oxide has a very dense structure. The gelation is very rapid, so fibers are very short. But when you have a 0.5% of zinc oxide, you have a very large fiber with a very good porous structure, and you have a very good high surface area. You can see when you have a 0.5% zinc oxide, gives a very good surface area of 407 meters squared per gram compared to other sample, and also have a very good optimum average pore diameter. You can ask why zinc oxide gives such a special, especially 0.58%. I already told zinc oxide is an amphoteric in nature, like an amphophile, so which can form a sodium zincate complex with the sodium hydroxide. So this sodium zincate can disturb crystalline as well as amorphous phase of the your cellulose and bring more amount of cellulose in the water system. So such a way your cellulose is surrounded by more water. So you have enough time to form the network. So which gives the fibers are very fine fiber with a long fiber and more surface area with a very good pore size. So zinc oxide, especially 0.5%, that is the optimum concentration. You can achieve the maximum solubility of cellulose. Apart from that, you are going to lose, you are going to have a precipitate of cellulose, and you are going to end up with a decrease in the other properties. Yeah, you can see the isotherm pattern of the all the beads and pore size distribution of the prepared beads. Yeah, so you can tune the property like morphology, bead surface area, even density. I didn't show because of the time constraint. Density as well as pore size distribution based on your application. Yeah, so this is with respect to pristine cellulose aerogel beads. So how about the functionalization them for a possible water treatment application? We all know water is the elixir. So people believe that third world war is going to come because of the water crisis. So we need to find alternative option to get a purify the water, contaminated water, because we cannot depend on only the natural resources which are keep on getting depleted. So we need to find different material which can purify the wastewater, either domestic or industrial wastewater. So especially magnetic. So when you have a magnet, so you have a absorption property as well as you have a easy collection of the beads after removal of your metal contaminant. So you can functionalize the cellulose beads with a iron oxide nanoparticle, so which has a attractive to selective metals. In order to give more functionality, you can functionalize them with a silicon nanoparticle. So then you are going to increase the selectivity of your material for more other metals. And also you can incorporate a silver nanoparticle into the system. So along with the iron oxide, you have a magnetic stability. With the silica, you have more selectivity and towards attachment of silver. With the silvers, we all know we all have, everybody have especially we all have a silver vessels in our so it has a more antibacterial or a anti-microorganism property, so which can kill the organisms present in the water. So by such a mechanism, so you can have a dual characteristic of oxidative catalytic property as well as killing the biological pathogens present in the water, and also you are going to remove all the toxic metal contaminants, especially with respect to electrochemical industry, metal industry, yeah, even your day-to-day usage of anything. So it has a fascinating application of treating all the metal contaminated polluted water. So so with this, so then later at the end of my work, then I moved to India and worked as an assistant professor in MITS for 3 years, approximately 3 years. Then Professor Barbara called me back to join our group, and she asked me to give another interesting field. So I first started my career with silica aerogels, then switched into biopolymer aerogels. So from inorganic to organic biopolymer, then organic, more organic polymer. So currently I'm working on development of resorcinol formaldehyde aerogel microparticles. So this is also another dimension. So starting with the monolithic to microbeads and microparticles. So I have a chance to work on all the dimension on all the fields of aerogels. So I'm working with as part of the project called Aeroprecast. So our aim is to optimization of aerogel granules and upscaling of the production to the pilot plant scale for their use as a core strand additive in the foundry. We all know foundry industry is one of the demanding industry which has a huge application, especially molding of many metal parts. As long as we are using metal, so always the foundry industry demand is going to be high. So yeah, we all know we are using wood adhesives, polymeric resins, thermosetting resins. So it's also kind of a thermosets, resorcinol formaldehyde. So in the past, Pekala find a way to form a resorcinol and formaldehyde based aerogels. So they are organic in nature. So they are the precursors for preparing carbon aerogels. These carbon aerogels find excellent applications. You can see electrodes, battery, foundry, and adsorption. Especially electrochemical industry has a huge potential of applying carbon aerogels and carbon-based materials. With respect to our project, we required nano-structured materials to act as an additive in the foundry industry for sand cores and mold. Because in the past we had our group had an experience that when you add aerogel granulates as an additive, which gives a better property to the sand cores and mold with respect to strength and defect reducing property. But the problem, you have to prepare the bulk monolithic like a 100 kilogram or 200 kilogram, 300 kilogram. Then you have to mill it and grinding it and sieving into the size what we want. So it's a huge process, starting from a bulk monolithic and end up with the milling and sieving into a smaller particle. So it's takes more time, more cost. So that's why our idea is to go with directly to the microparticles of the range what we require. So people already worked on developing microparticles, but mostly on biopolymer particles using different methods. There are few reports available with respect to these organic aerogel microparticles. This also has one of the huge potential. Yeah, you can see the reaction is very easy. You have a resacinol, formaldehyde, so mixed together. The reaction will go at room temperature, but it's very slow process. So you have to initiate by adding either the acid catalyst or base catalyst. So depends upon the catalyst, you can change the gelation time and its properties and morphologies. Yeah, this is a picture of aerogel produced in our group. You can see the SCM pictures of aerogels produced by acid catalyst method. They are very nanostructured and particles are very uniform. So with these RF aerogels, you can prepare a very good nanostructured materials. So, but yeah, what is the problem? What is the need to prepare these kind of RF aerogel particles for foundry industry? So yeah, we all know in the casting process, we are going to cast the mold solution, metal solution into a mold. So you're at high temperature. When you're casting a solution at high temperature, the sudden impact creates the cracks and different defects. So because it is going to experience a higher temperature above 1000 degree, and at the same time, there will be some effects, some chemical reactions happening when the mold is in contact with the metal solution. So some toxic gases may evaluate. So this is going to create this is already creating a problem to the industrial people in terms of reproducibility of the mold as well as the toxicness such evaporated from the system. So sometimes these aerogel particles have a nanostructure, so they have the capacity to absorb some gases and give more strength to the sand cores. So such a way we can eliminate the cracking. So you can see the cracks happened when you cast them with metal mold. So it happens to blowhole and veining. So it has, so you cannot use such a mold for multiple time. So you have to throw it. So one time use. So it limits the multiple usage of your mold and also creates toxic gas emissions. So nowadays, the entire Europe is going with the sustainability to reduce the carbon dioxide emission. That is what after the corona, the German government has took a leading initiative in terms of sustainable Europe. So I think yesterday they come up with a huge financial package of sustainable Europe. So it is one of the interesting and potential area for any process with the development of sustainable process. Yeah, you can see the picture from our group. So we have developed sand core additives with brass and aluminum without aerogel additives and with aerogel. You see the difference in smoothness and finishing of the product. So especially these aerogel additives have a very good property in terms of smoothness to the sand cores as well as stability and toxic gas absorption property. So there again, so these particles are 200 to 1000 micrometer in range. So because of the easy process, easy handling, so people are it's in a huge demand. So there are a lot of processes available in like a dripping process, a jet cutting, water emulsion process. Each process has its own advantage and disadvantages. At the laboratory level, we try to use emulsion gelation method. It's like a basic, just to take a water, mix with oil, or take a oil, mix with water. So you are going to develop a droplets. So instead of water, we are going to use our reaction precursors under heating or different conditions. So we are going to end up with the product what we want. But the problem is that again, washing the oil, that is the huge process. So yeah, it has a huge potential, but it has a disadvantage of for bulk production. Yeah. So with respect to my work, so using RF aerogel particles by emulsion gelation method, so I prepare resacinol formaldehyde based salt solution with respect to different composition of the resacinol formaldehyde and catalyst. So we use easily available oil phase for the possible production. So always we have to think about sustainable process with the cost effectiveness and possible bulk production in terms of industrial production. So then it can be used for mankind. So anybody, those who are interested to take up research, so you can think of designing any process and develop a material which has a sustainability and possible production, and it can be used for any application of the mankind, not only mankind, to the nature or any other living creatures that we are sharing the world. So I already mixed the RF solution with the oil phase and the stirring. So since RF solution has a higher gelation rate with respect to temperature, so under stirring with respect to 60 degrees and temperature, they form a stable RF particle. So after some time, leave it them in the oven for curing. So because of the gravimetric sedimentation, they are going to separate. So the lighter oil phase will go down, heavier aqueous phase will come down. So we can remove most of the oil by manual filtration. Then what are the oil sticking with the RF particle can be washed with solvents, multiple solvents, or the solvent which can give a better extraction of your oil. And we go for a supercritical drying. So this also another problem with respect to industrial production, because this supercritical production involves supercritical CO2, again cost of production, safetiness. So we always try with both the process to see the feasibility. So we try supercritical drying as well as ambient drying. So this is the simple process. I just used a simple water bath in a small plastic sample container, mix the solution at under stirring at a temperature. So you are going to end up with the RF particle at the bottom and separation of oil at the top. Then washing your solvent with some organic solvent like ethanol, acetone, or whatever you want, feel the oil can be extracted maximum. Then we pack them in this kind of tea bags. It's a basic tea bags we use preparing tea. So such a bags and put it into the supercritical dryer, that is autoclave. Then we come up with the fine particle. Yeah. So this is the overall composition I have used. So RC, this means resacinol to catalyst 200, resacinol to formaldehyde 0.74, and resacinol to water 0.044. So overall, I have used an oil water ratio of 1:3, because when you have a 1:3 ratio of oil water, you have enough liberty of form with the stirring and give a space to form the particle. Because I tried with 1:2 and 1:1 ratio, but the optimum concentration, even in the literature, and I also found that as a 1:2 with a temperature of 60 degrees Celsius. As I already told, I tried both drying methods, that is a supercritical drying and ambient drying, to see the properties of the material. So overall, all the sample has the skeletal density of close to 1.42, which is a typical density of RF. Yeah, then you can see the morphology, overall view, particle distribution of the particle. So approximately we have end up with the particles of 200 meter. So you can see there are a wide distribution of the particle. So this is one of the disadvantage with respect to emulsion process. So washing, one is oil washing, another one is you have end up with a multi distribution of the particle. So yeah, so you can see the particle distribution of from the left side is a supercritically dried, and the other one is ambient dried. So that looks fine, similar, but there is a huge difference in the adsorption property, especially with respect to surface area and pore size. In the right side, you can see the BET adsorption isotherm of your prepared particle. They are typical mesoporous material. They do not contribute for any micropores. So yeah, so I have tried different curing time to see is there any effect on the curing time. So we tried with you can see 14 hours of curing, then 24 hours, 48 hours, then 72. Then apart from that, I tried with stirring, changing the stirring speed. So you need to have a minimum optimum stirring speed to get a uniform particle particles with a stable structure. When you have a higher stirring rate, you end up with a very smaller particle. So overall, the BET results shows that the samples prepared at 24 hours of curing gives a very optimum BET surface area with 285 meter square per gram and a good pore size distribution of average pore size diameter of 11.09 nanometer. But although the other samples with the 48 and 72 hours have a higher surface area, but they looks like a more brittle, more because of the longer time they get more brittle in nature. So I feel that we need to have an optimum curing time in order to get the best property that we need it for a foundry application with a good nanostructure, good surface area, and good pore size to give the strength what we required, as well as the toxic absorbing capacity. So still I am working on to give a to come up with a better material for that is suitable for a foundry application. So some of the slides with respect to RF aerogel particle, all the results are unpublished. Yeah. So with this, I would like to give a summary to my talk. So yeah, you can see the overall global demand of aerogel with respect to industrial production or industrial application in various field. So yeah, there is a demand for silica, organic polymer aerogels, carbon aerogels, even biopolymer aerogels in the form of insulation blanket, panels, insulation panels, as well as aerogel um, aerospace application panels, and RF aerogel particles. Then monolithic for oil absorption, electrochemical applications, and films, fibers. So you can see overall the trend, the demand of aerogels is going to be from 2009 to 2026. There will be a huge increase of around 12% demand throughout the world. So throughout the world, people are working on these kind of material to come up with the best. And also a lot of companies like Cobat, BASF, Aspen, they already have they already working on it in the long time. They have a production. They have production also. So overall, you are going to have a US dollar of 1,122 million euro in terms of financial business in 2026. And also you can see the wide application starting from oil, gas, industrial to cosmetic and windows. So mostly these aerogel materials have a huge application in oil, gas, and transport industry. You see the contribution percentage is going to increase from 2019 to 2024 and 2029. So yeah, we have a very good material, easy process, huge demand. So yeah, that's why these aerogel materials are going to rule the world in the future with their multi-property and multi applications. So definitely you have a huge potential in the future. So yeah, with 1 minute. So with this summary, I would like to conclude my talk by giving the thank. So we all know we have a very famous Tirukkural in Tamil. Ennandri kondarukkum oivundam oivillai seinandri konda magarku. So the one who forgets the help rendered to him, he will not get the heaven in his life. So such a way, I would like to thank the people or the inspired persons who have contributed throughout my career in this work. Especially, I would like to emphasize Professor Barbara Milo for giving me the opportunity to work in 2015 with our group and in 2019 also. So I must thank for giving me such a wonderful opportunity to work all the fields of aerogels, especially biopolymer aerogels and organic aerogels. And also, yeah, I would like to thank my PhD supervisor, Professor Dr. A.B. Mandal, who is a former director of CLRA and currently the INSA scientist at CSIR Central Glass Ceramic Institute, for his inspiration and guidelines and support throughout my career, starting from PhD until today. Yeah, today morning also he wrote me a message that your link is not working. Then I told him that, sir, 11 o'clock we are going to start the presentation. So thank you, sir, for your wonderful support throughout my career. And also, I would like to thank Dr. S.N. Jaishankar, scientist from CLRA Polymer Division, who is my co-supervisor. So although my supervisor is a direct supervisor, supervisor is Professor Mandal, but most of the time throughout my PhD, 5.5 years, I worked with him, Dr. Jaishankar. So who never treat me like his student, like he's like a colleague. We have an open discussion, lot of help in terms of professional as well as personal things. So I must thank him. And also I thank Professor Lawrence Radke, our former head of the aerogel department, for giving me an opportunity to work with him and Barbara in 2015. So I also thank financial support, especially like a research in a developing country. Like in Germany, we can there is a possibility of getting fundings a little higher, but especially in India, we need to get more funding. So I must thank all the funders from India as well as Germany. So Central Scientific Council of Scientific and Industrial Research, CSIR, in terms of my research fellowships like a research intern and SRF and travel grants also, and DST also, because I during my PhD I had a chance to present my work in Australia. So I must thank DST for the travel grant, and also I got a 30 lakhs project along with my colleague Dr. Arun Babu. So I must thank Dr. Arun Babu also. He's my senior. I started my career with him. So now then later we become a colleague. So now we are working on a project from converting tomato plant waste into possible product at MITS Madanapalli. So thank you DSD and Dr. Arun Babu. And I also thank DAD for the postdoctoral fellowship, and I must thank DLR for the current employment as well as the for the previous DAD postdoc fellowship. And also I must thank all my colleagues, because without their support you cannot have the feeling of a good atmosphere. So I must thank my colleagues at CLRA and DLR. And finally, coming to the current talk, I must thank our management and our principal, Dr. Jayakumar, for giving me such a wonderful opportunity. So it's a great feel for me to present my work in front of my professors, whom I have learned all the knowledge and all the resource I have utilized. So thank you to the management and principal of APSA College. And I must give special thanks to my professor, Dr. Susai Manikam, current HOD and of the chemistry department. I would like to thank my previous HOD, Dr. Alvarapan. So when I complete my third year, they were the two faculty members where they struggled a lot to complete all our syllabus and give our maximum efforts in 2006, because with the shortage of faculty, they could able to manage us to come up with the best students for our batch. So, and also I thank the current faculty members of chemistry department, so for giving me this opportunity, and all my teachers and professors. So they are the shapers of me. So I must thank the Almighty and my parents and my family. So finally, I would like to thank all the participants of this webinar for their kind patience and registering themselves and attending this webinar. So this is our current group picture at DLR in 2019. So you can find Professor Barbara Milo, and so backside of me, I'm standing. All my colleagues are standing. So we have a wonderful team at DLR. So we are working on different fields. So we work for our professor guides for work for industrial project, DLR related mission projects, and we work on and also she hold a professor position at the University of Cologne. This is one of the oldest universities in the Germany. And also we train a lot of students for their bachelor students, school practicum students, master students, and internship students. So yeah, if you have any interest to work with us, you can contact our professor. I already given the contact detail. Maybe I can share one more time the contact detail of my professor. So yeah, finally, I'm open for any discussion or any questions that you would like to get me answered. So 1 minute before going to the Q&A session. Yeah, you can find the contact details of my professor, Professor Dr. Barbara Milo, who is the Deputy Director and Head of the Department in our institute, as well as the Professor at the University of Cologne. If anybody would like to get clarification from anything, you can write to my professor, and you want to do or collaborate with us, you are open to any kind of collaboration from us. So thank you one and all for the wonderful opportunity.
Thank you, Sinimira.
Yes,
Wonderful presentation, and also you have given directions for the future researchers. Thank you.
There is one question from Dr. B.M. Ashwin.
Okay.
He like to have a view about luminescent aerogels and its applications. Do you have any idea?
Maybe can you tell me where he from, sir? That's also good for him to know.
I don't know where he's from, but Dr.
Okay.
B.M. Ashwin, you can contact him, Dr. Serimira, and
Yeah.
can consult it privately.
Okay, so no
I
problem. I
think
can
that's
answer,
okay.
sir.
Yeah,
I
you
can answer.
can.
There are some aerogels. I already told we already worked on vanadium aerogels. There are some luminescent aerogels, especially these kind of aerogels with luminescent property have a huge application in forensic detection. So especially when crime is happening, you have a fingerprint. So it's a it's a very light impression of your fingerprint. So you have a luminescent aerogels when you make the powder and put it there, so which will have an impact with your aerogels and fingerprint. Later you can trace them with a luminescent light. So yeah, there are applications with forensic detection of your fingerprint in the crime scene.
Okay, I hope that gets his answer. And if there is anybody, you can raise your hand for further questions.
Shall I unmute all?
Yes, yes.
Yeah, even you can give them to talk with me also, sir. That's good for them.
Yes, yes, yes.
You unmute those who are raised their hands.
Logo is some. You need some answers from you. Should I unmute him, or I shall ask the question from the comment box? Could you see the comment
Yeah,
box?
If there are very few
1 minute, sir.
persons
I
unmute.
can 1 minute. So,
Either
yeah.
unmuted or everyone.
No,
Maybe
no,
you can
Everyone is
select
active.
only one person to unmute
sir.
because I
Only
did not
those who
see
are
the
raised
chat
their
box.
hands.
Yeah, 1 minute. Yeah, I have seen the question, but there are a lot of questions, sir.
Yes, yes, yes. You can carry on. Can carry on. Can answer one by one.
Uh, Maybe I have
KPG
to
sir.
find
Yeah.
where the from the first question starts.
Logo. From logo, there is one question. KPG sir, you can mute all the participants.
Okay, okay. Okay, I can proceed now.
Question from Dr. Logudurai, my former colleague. Damage on one side of the aerogel where heat, high temperature is applied, whether it can be avoided, how it will be cured, like self-healing, any chemical methods for graphene-based aerogels. Yeah, coming to the last question, there are aerogels available based on graphene. They have excellent electrochemical property and oil absorption capacity. With respect to self-healing, there are self-healing polymers. I have never seen. It's another interesting. Nice question. It's another interesting area. We can maybe later anyone from the audience or from our group can come up with the self-healing aerogels with respect to temperature. Yeah. So far, you have an impact of temperature, especially with respect to high temperature. In my knowledge, so far, nobody has developed a self-healing aerogels on the impact of temperature. Yeah, the other Dr. S. Premalada. So ionic liquid usage is hazardous in my view. Yeah, you are correct. I already told when you use imidazolium based ionic liquid, they are hazardous. Yeah, but when you use a biocompatible ionic like choline formate or choline saccharinate, especially recently people developed ionic liquid based on sugar salt. So choline saccharate. So both anion and cation are biologically compounds. So they give an excellent stability to biomolecules at room temperature, and also they act as a buffer solution. Currently, we use a buffer solution to stabilize the protein and stabilize the pH. So even the mixture of the ionic liquids can act as a buffer or eutectic solvent to stabilize them. So there is a potential scope in developing bio gels using without any hazardous nature of developing aerogels from ionic liquid. Then Dr. Kalidasan, how did you manage the counter ions from the ionic liquids? Yeah, especially I'm not the expert in ionic liquid. Since I used only ionic liquid for preparing my material, you can go through the work from Professor Douglas McFarlane from Monash University, Australia. They work a lot on this kind of ionic liquid materials from imidazolium to bioionic liquids. So you can go through their publications. You will get a more insight. Yeah, any more questions, sir? Needs to be answered. Okay. Okay. So any more question I have to answer, sir?
Is there anybody to ask questions? You can raise your hands and questions will be answered. You can raise your hands using this reactions, or you can post it on the chat box.
Yeah, you are welcome to. You are welcome to do anything, whatever you want.
Yes, 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 yes. Okay. And participants, your feedback link is given on the chat box. Also, it is posted on the YouTube. Post your feedback, and you can receive your certificates after submission of this feedbacks.
Yes, sir. Maybe I just like to make only one comment to the young student community. Those who are from
Yes.
my place, my birthplace, Tirupattur. So there are a lot of things happening in the throughout the world. So don't look at the negative things. So just to focus like a horse. So always negative things will be in there in the system. So no need to look into that, especially social media. So just to focus on your aim, anything, whatever you do, give your best with the patience. Definitely you will be rewarded from the super source. So that's what happened to me. Apart from the human help, always I got a help from the the Almighty. So definitely go ahead with positive thoughts. Give up your best.
Thank you, Sinimera. We can
Yes, sir.
proceed with our program.
Yeah.
Thank you very much for your nice presentation and thought-provoking presentation. And also,
Yes.
Okay.
Yes, we have to go to the vote of thanks.
okay.
Yes, carry on.
It's mandatory to thank each and everyone behind a successful program. On this regards, on behalf of the organizing committee, it gives me immense pleasure to thank our management and principal who backed us with their moral support. I thank the resource person who had given an enlightened speech. It is very useful for the researchers and inspiring for the students. I once again thank him for the acceptance of our request for the talk in between his busy schedule. I thank the participants from various institutes and their active participation, which made the session lively. I thank the students and the alumni for their committed involvement. Finally, I thank each and everyone, those who directly or indirectly helped us for the success of this webinar. Thank you.
Shall we go for the national anthem?
Yes.
Okay. Then I must stand.